Okay, so the discriminant test is what we're looking at today, okay? And it is day 6. So A day it's Friday, B day it's on Monday. But I wanted to make sure that we covered this discriminant so that you understood the Pearson homework. Alright, so the discriminant test is looking at, whoops, go back. First of all, let's do, it's still discriminant, but we're going to look at some quadratic formula stuff for practice, for warm-up practice. My equation is 2x squared minus x is equal to 4. Okay? So I'm going to go ahead and incorporate it right now, both the discriminant and the quadratic, so that you can understand what we're doing. So I would see 2x squared minus x is equal to 4. And my first go-to would be to set it equal to 0. Okay? Trying to solve this out by hand, I would have 2x and x to give me that 2x squared. Okay? That's this product here. And then I would look at factors of 4, which I could use 2 2's or a 4 and a 1. And my goal is wherever I strategically place these, I'm trying to get a negative 1 as my b term. The negative 1 will come from these two multiplied, but then added together. Okay? What do y'all think? 2 2 or 4 and 1? 2 2. And so with it being 2 2, I would have a 2 and a 4, which would either give me a 6 or a 2. Did it work? No, no worries. So I will quickly just go back, and instead of 2 2, I will use now what? 4 and 1. Where could I put the 4? Where could I put the 1? 4 first, 1. So now look, I have 4 and 2, and I will either get a 6 or a 2. It still didn't work. Okay? So maybe I placed the 4 and 1 incorrectly. Maybe that I should put the 1 first and then the 4. This is my last option. Other than trying to change these. No, this is my last option. Okay? So I have 1 and 8. I will either get a 9 or what? 7. None of those work. I still fervently believe that this is the best go-to that you should do as far as factoring like this. Because you're building number sense and you're getting a lot of practice. Now, if they don't work just like this, you have to go to the quadratic formula. Okay? So before we do the quadratic formula, I'm going to show you something. We've talked about it here and there before, called the discriminant test. And the discriminant test is about to tell me what kind of answers am I going to get before I do all this work. Because this is a lot of work. And before I do it, I want to know what type of answers am I going to look at getting. Okay? It's like you know what you're going to be getting before you even try to do all this work. So the only thing that I have to do with the discriminant test is this piece right here. And if you saw the way we went through that, deriving the quadratic formula from scratch, this is the most important part of that quadratic formula. Okay? What's B, guys? Negative 1. What's A? And what's C? Negative 4. So if I looked at this b squared minus 4ac discriminant test, I'm not even kidding, 5% of people remember it, but it's, I would say, tested at least 90% of the time on SAT, ACT. B squared minus 4ac. What number would I get? What is this first part? What's negative 1 squared? 1. What is all this equal? 32, right? A positive 32. So this gives me 33. The only thing that I care about it is not that it's 33. I care that it's positive. Because if it's positive, I will get two real distinct solutions. It will be two answers that are different. They could be decimals. They could be whole numbers. But it would be two answers that are different. If this was not a positive and it actually gave me a negative, it will be two non-real solutions. And these are talking about square roots of negatives that you will see are equal to i's, imaginary i's, lowercase i's. And we'll get into that. Not today, but we will get into that. And then the last thing that it could be, if it wasn't positive, negative, it could be equal to 0. And if it's equal to 0, it's one double root. It's the same answer counted twice. Let me show you what those graphs look like, just real quick, a quick sketch, so that you understand what you're looking at. So positive discriminants versus negative versus 0. A positive discriminant will have two x-intercepts that are different. A double root will just have one x-intercept that's counted twice. Because look at that equation right there. 1, 2, it could be something that looks like this. X minus 3 squared. That could be the equation of that. And we've learned recently that this is the same as counting it with the multiplicity of 2, where the answer here would be 3, this would be 3. One double root, same answer counted twice. Okay? Two non-real solutions, it still bends. It just never touches the x-axis. Let me give you a really, really good example why. Let's say I had x squared and I shifted it up 3. This graph would look like this. Do you agree? Okay. If I set this equal to 0, and I told you to solve for x, what would you do right now? Subtract by 3. And then you would take the square root, plus or minus, and you would get x is equal to the plus or minus square root of negative 3. Can I take the square root of a negative? No. That's why they're non-real, imaginary. And the imaginary part is really just referring to mathematically you can still get pieces. And all those pieces show is that there was still some kind of change or bend in that quadratic. Okay? But these real solutions, you don't get the square roots of negatives. That works out. Questions? The discriminant test is huge. So I got a positive answer. That tells me I'm not going to get any imaginary i's that are going to happen because I have square roots of negatives. I'm going to have numbers, real numbers. Whether they're decimals, which most likely will occur. And the reason why I know that they're decimals is because what I tried at the very beginning didn't work out. And if it doesn't work out what I tried at the very, very beginning, they're not going to be what we talked about at the very beginning of class at 8, integral answers. They're not going to be whole numbers. Okay? So here we go. So this didn't work out, so we have to revert to quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a becomes, we're going to still use this, negative b plus or minus the square root of 33. That's what we got, right? Did we get 33 for b squared minus 4ac? Okay. All over 2 times a, which is 2. So this is a good thing of doing the discriminant test because you're going to get that 33 anyway. So now not only do you know what kind of answer you're going to get, you also can get that square root piece already. So this negative times a negative will actually become a positive. So we'll go ahead and just write right now, save a little bit of time, positive 1. And the bottom is what? 4. So these weird answers with the square roots, they're decimal answers, okay? If I asked you to break up 33 to see if we could actually simplify this, what could I break up 33 into? 11 and 3. Can I take any one of those out? No, because they must be in pairs, right? Because of what we talked about last class, what number is understood to be there? 2. Did we not talk about that? The square root, by default, the 2 should be there. We don't write it, but that means they come out in pairs of 2. Okay? For instance, real quick, since we didn't talk about it, 32 can be broken up into 8 times 4. Can be broken up into 2, 2, 2, 2, 2. Okay? So there's 5 2's that you could write. That's the same as taking the square root of 32. If nothing is here, what number's understood? 2. That means they will come out in parties of 2. This 4 will come out as 2. This 4 will come out as another 2. And this 2 that didn't have a pair will stay in there all by itself. So that the simplified form is 4 root 2. You'll see some that very soon, what if it wasn't the square root? It was the cube root. It comes out in parties of 3. So this will now come out as just 2. Can these come out? No. They need a party of 3. So they would stay in there as 2 times the cube root of 4. Okay? So since this one doesn't have a party of 2, the 33 is going to stay there. And I have 1 plus square root of 33 over 4 and 1 minus the square root of 33 over 4. So x equals that, x equals that. Because mathematicians are lazy and don't want to write both of them, that's why they do that. Just to account for both. Yes?
So with the simplified version of the example you gave above, could you add anything to the 2? Like if it was like 3 plus and then that, could you add the 2 to it? Or
3 plus, can you write what you're talking about real quick, just right here? I want to understand. Oh my gosh. What you're saying. Because, I mean, I'm not even kidding right now. What we're talking about is one thing that people in calculus struggle with, and they feel calculus is difficult because of calculus. It's not. It's because of algebra too. They don't have their skills refined.
Meant like if it was 3 plus and then you took that, could you add these 2 together or
Okay.
no?
That's an excellent question. Okay. So, ready? 3 pencils. It's not a trick question. Plus 2 pencils. 5 pencils. 3 pencils plus 2 pens equals what? You notice how you didn't combine those together. You kept them apart. So that's why when I say 2x plus 3y, does this equal 5xy? different denominations, different terms, different families, if you will. And this right here, the family that this is associated with, is anything that looks like that. Okay? So if I said that this stood for X, I could rewrite this, that Catherine was asking, as that. And can we add those two together to get 5x? No. Do you understand? Okay. Excellent question, too, because a lot of people struggle with that. But you are doing this right now, okay? So that's why I want to show you. How about if I had this? Don't be afraid to make a mistake. Please let me know what you think. What do you think the answer is to this? The square root of what? Square root of 6. What do you think the answer is to that? It's not the square root of 5. Square root of 3 plus the square root of 2. Because this family is square roots of 3 family. This family is square roots of 2 family. So it's like saying pencils and pens. You can't add them together. But you can multiply them together. You should ask why. Why can you multiply them but you can't add them? Because look, 3, square root of 3 is this. The square root of 2 is that. They're from the same family to where I can't add them per se, but I can multiply them to look like this. Because with multiplication, this is a huge thing that people struggle with, especially in calc. With multiplication, you have a rule that you can apply it to both of them. But with addition, you don't apply it to both of them. And it all stems from the, I think, day 2 notes that we took of perfect trinomials. A times b squared is the same as what? A squared times b squared. But what is it if I add? Is it a squared plus b squared? No. It's totally different because we have to FOIL these two pieces. Do you understand? Okay, so enough of that. So your 2 answers will be over here. They are decimal form, and you're good to go. Great questions, great questions. We're knocking both out at the same time, discriminant and quadratic with practice, and there's your answers right there. And right here, I don't like this word because it suggests it could be one or the other. I think it should be what? And, because it's both the answers. Okay? Alright, so let's go to, there's another quadratic formula practice. Let's go to, oh, this is what I was showing you earlier, guys, in the notes. Whenever you have a positive, greater than 0 equals positive, you'll have 2 answers. Right there, or right there. If it's equal to 0, it's 1 answer. That's a double root. And those are like those horizontal shifts left to right. And if you have a negative, then it will never touch the x-axis. Okay? Alright. And these are those imaginary roots that we were talking about, that we will get into soon. Let's go now to, let's see. And when I mean soon, I didn't realize it's today. Alright. So the square root of negative 18. All extensive purposes. The 2 that I want you to memorize right now is that the square root of a negative 1 will give you an imaginary I. Okay? For right now. What if I squared, not square rooted, but squared both sides? What would I have? Negative 1 equals what? I squared. And to me, you need to memorize both of these. I think the easier one for me growing up to memorize was this one. I squared is equal to negative 1. Because how can something be squared give you a negative number? So it's not real. So with that being said, then I would go to this one of, okay, if I square root both sides, I is equal to square root of negative 1. Okay? Are we good? So now, when I have a square root of a negative 18, when you factor it out, so look, they have, let me show you the work. I don't want you looking at that. Let's do this together. If I broke up 18, and I'm doing prime factorization. Did we do primes last class where I said 2, 3, and y'all listed them all out? All the way to like 23? We didn't do that? What did you do last class? So, 2, 3. So a prime number is a number that when you multiply it by 1, those are the only factors that you can multiply to get the number that I'm talking about. Okay? So if I said, is 20 a prime number? What would you say? No. Because not only does it have that, it has other things that you could do to multiply. It has other factors besides just 1, and itself. So prime numbers are whenever you only have those two factors and nothing else. And these two numbers cannot be the same. They can't be the same. So what's your smallest prime factor? 2. Why isn't it 1? Because it's 1 and 1. And these two numbers cannot be the same. Okay? So prime numbers start at 2, 3. Keep going with me. 5, 7, 11. Why isn't it not 9? Because it's 3 times 3, right? So 11, 13, 17, 19. And why is it not 21? Because 7 and 3. So 23, and we'll stop there. These are prime numbers that you are trying to break these down to. You're aiming for these numbers to be at the bottom of these branches. Okay, so here we go. 2 and 9. Whoops. Let me do it like this. 2 and 9. I know to stop here at 2 because 2 is prime. So no more breaking that one up. But then I can come over here and next level break this into 3 and 3. And I know I need to stop right here because 3 is prime. So 18 is the same as 2 times 3 times 3. We talked about it. What number is understood to be here? 2. So will these party of 2's come out as what? Just 3. Not 3 times 3, but just 3. Because right now this is 9. And the square root of 9 comes out as a 3. The 2 stays in. What else is still in there that I haven't written? The negative. Does the negative come out? Is my question. The negative does come out. Even though it's not in a pair, this is where the imaginary numbers come into play. Because if it was in a pair, it'd be positive. You don't need to bring anything out. But the negative will come out as an I. Exactly. Like what? As an I. So the I comes out, it joins the 3, and the square root of 2 is left inside. Questions? So, okay. So this is my answer to the square root of negative 18. Or negative 18, yeah. Can someone tell me, why do I not have, it's important, subtle, but important, why do I not have a plus or minus answer on this? Let me ask you this. What's the square root of 4? 2? 2 or plus or minus 2?
Oh, it's because it's a negative 18.
This is just 2. Okay, let's try this again. What's the square root of 9? 3. No plus or minus, right? Good. What would be the square root of negative 4? 2i. What's the square root of a negative 9? 3i. The reason why I don't have a plus or a minus is because all I'm asking you to do is take the square root of something. How could I ask you to give me a plus or a minus? Well, I could give you that. Solve for x. What do I do to both sides to solve for x? Square root. And look, when I square root this, I need a plus or a minus. Because then x will equal a plus or minus 2. And in my original problem, if I plug in a negative or a positive 2 for x, I will get 4. So what is it that I need to have a plus or a minus answer? I need a variable squared. I need like x squared, y squared, k squared, whatever. Do you understand? No? Do you see how this is just positive? Can you take the square root of 4 and get a negative number? Nope, I can't. But if I set it up like this, like an equation, that forces me to take the square root, there you go. You will get a positive or a negative answer. Okay? Subtle, but important. Alright. Any questions before I keep going? Okay. So let's go now to adding imaginary numbers. Here we go. What I have right here is 4 minus 3i plus negative 4 plus 3i. What number is right there? 1. Positive or negative? Positive. So does it do anything to this? No. So I could write that with no parentheses. What number is right here? Positive or negative? Positive. Does it do anything to this parentheses? No. If it was negative, it would, because a negative times a negative would be a positive. And a negative times a positive would be a negative, because you would distribute. Do you all understand what I just said? Okay. So now we're going to add a negative 4, which is the same as just doing what? Minus 4. So a positive times a negative is a negative. A positive times a positive is a positive. Again, this negative and positive give you that, and this positive and positive give you that. So what's my answer? 0. 4 minus 4 would combine like terms. Negative 3i and plus 3i would combine and add to 0. Are we good? Okay. That's adding i's. What if I were to, and this is what we're going to do, really. What if I were to multiply these binomials? Okay, so we're going to follow this out. Here we go. Riley, what do I get for my first term? Negative 16. Sarah, what do I get for my outside terms? Joel, what do I get for my inside terms? Positive or negative? Yep. Corbin, what do I get for my last terms? Be careful.
Negative 9i squared.
That's perfect. Negative 9i squared. Okay? Let's combine all like terms. Are these like terms? Yeah. What would I get? 24i. Uh-oh. Are these like terms? They are. They are like terms. Because what is I squared? Negative 1. So it's negative 9 times I squared. This is actually what? Plus 9. So a negative 16 plus 9 is a negative what? Negative 7? Yes?
So I represents negative 1, right?
Yes. No. I represents the square root of negative 1. I squared represents negative 1. Yes?
Is I squared always going to be negative 1?
Yes.
Or is it going to change?
Nope. It will always be that. I squared is always negative 1. Okay, we will look at other stuff. But right now, I just want you to know those two. There's 4, but I'll show you the other ones later. Okay, but for these, that's why I go to this one, because that's what's tested. That's what pops up right here, mostly whenever you are trying to figure out and combine like terms. Okay, that's why I tell people to memorize that more than the other one. Okay, so 24i minus 7. Is this the same as if I were to write it like this? It is. Okay? Which one do you think I prefer? The top or the bottom one? I actually prefer the bottom. Because in your answers, when you're doing quadratic formula, you're used to doing negative b plus or minus the square root of stuff. And if you're taking the square root of a negative 1, that I is going to be on the right side of the plus and minus. Do you understand? And the way it equals, and it looks like this. B plus or minus AI. Where B is a number, A is the coefficient of I. Okay, we'll look at examples right now in just a bit. Okay. Questions before I keep going? I know it's new, and I know it's a little bit like, what's going on right now? But all we're doing is still fully factoring and incorporating the discriminant test and now imaginary numbers. And we looked at the completing the square as well. Practice. It's all correlated, all these together. All right. So let's go to the next part, which asks, what is the product, basically multiply this stuff together, of these terms. How many terms does this represent? 1. So it's a monomial, right? Mono for 1. This is a what? Binomial for 2. But because it's multiplied here, I can look at this as one huge monomial. Okay, here we go. So let's find the product. What do I do? What's my answer? Negative 15i plus 6i squared. You see that? All we did was just distribute. What's I squared? Negative 1. So what are we really doing here? Subtracting 6. Is this negative 21i? No. Because I can't combine them because I'm looking at pencils and pens. You with me? So, yeah. Okay, you mean like square root right now?
No, I mean, never mind.
No, I'm trying to understand your question. Say it again.
If you, because I is equal to -1. I mean, square
Oh,
root of -1.
I see where you're going with that. Okay, so he's saying, could I do it like the way we substituted in for I squared, a -1? He's asking, can we substitute this in? Okay. I mean, it's a legit question. Tyson, what do you think this equals if I were to multiply that right now? It would stay the same. Because that -1 is not going to be positive. Because no matter what, this is still going to be I. So that's why we don't substitute that back in. That's a really good question. We don't substitute square root of -1 where we see I. That's probably the best question so far today. We leave I as I. But where we see I squared, we do substitute what? -1. That's why I want you to memorize the I squared more than that one. And just leave I's as I's. Cool? So 1I leave alone. I squared, change it to -1. Okay. Do you think I would prefer this? No, I'd probably want you to write it as what? -6 minus 15I. And the reason why is because of how you're tested. That's the way you're going to see it most predominantly. Okay? Note both. Alright, so let's keep going. Here we go. We are going to, I think we're good with quadratic formula. The only thing that we need to do is practice with simplification of a quadratic formula, because now we have some that incorporate imaginary numbers. Okay, so here we go. I mean, all it is we're just looking for those square roots of -1. You know what I mean? That's it. All right, so if I asked you to factor this, and I gave you free rein to do it however you wanted, my hopes are that you would do the following. That you would go to 2x and x to give you the 2x squared. That you would think of numbers that would give me the 5. Okay, so 1 and 5. But I can't write 1 and 5 here and see what I would get. Because that needs to be 1 for you to be able to go all that way. So if I put 1 and 5 here, I would write a 1 and a 10. And I would see that this would either give me an 11 or a 9. That's not an 11 or a 9. So this doesn't work. This is that number sense approach. So maybe, since 1 and 5 are the only factors, maybe I was supposed to switch them up. I'm modeling exactly how I hope that you factor on the test and quiz, okay? So now I have a 5 and a 2, which will either give me a 7 or what? Or a 3. Look at that. It works. I don't have to do quadratic formula if I don't want to. I could get it right here. All I would need to do is line up my signs to make them work. So I need these blue ones to multiply to a positive 5. And then whatever these are here, whoops, let's do orange, to add to give me a -3. So what should the 5 and 1 be? Positive or negative? Which one's positive? Which one's negative? -5, positive 1. Or, yeah, you know what I mean. So I will get -5 times positive 1, check. -5, positive 2. When I add them, it works. Oh, I didn't get the positive 5. My bad. I didn't get the positive 5. So this won't work. Even though mathematically it works here, the reason why I showed you this is so that you can experience if it doesn't work, what do I do? Okay? If it doesn't work, what do I do? And these are not just random guess and checks. They're strategic guess and checks, or trial and error. So what you're going to do first is the discriminant test. And then this will tell you what kind of answers you're going to get. So that whenever you get your answers after doing the quadratic formula, you trust what you see. Because the discriminant test told you, hey, you're about to get these kind of answers. You're not just randomly doing something, not knowing what you're supposed to get. Okay. Here we go. And you will experience that what we just did, and I want you to. If you're not, you're doing too much work in the end. Alright, so let's go ahead and do the discriminant test. The discriminant test is what? What equation? B squared minus 4ac. Here we go. What's b? Negative 3. What's a? What's 5? Or c is what? 5. What's wrong with what I wrote? I need parentheses, especially if you're going to put some of these pieces in calculators. Because if you don't put parentheses right here, you're going to get a negative 9, rather than the positive 9 that you should get. So, what's the rest of this equal to? Minus 40. So what's this going to give me? All I care about is it's going to give me what? A negative. And the fact that it's a negative, what kind of answers are we going to have? Non-real solutions. 2 non-real solutions, which means I'm going to have answers with i's in it. You with me? I'm going to have answers with i's. You're going to be looking right back at, no, I'm just joking. All right, so let's do this quadratic formula by doing negative b plus or minus the square root of b squared minus 4ac. Now, I know I didn't write it down, but what did this give us? A negative what? 31? All over 2a. We're good? So the bottom is not 22, it's 4. And this negative negative is just a positive 3. And you can see it. It's looking right at you, pun intended. What is right there? There's an I that's going to come out. You can do it now if you wanted to. Or you can bring it out when you bring out whatever else comes out from the square root. Is 31 prime? 31 is prime. Okay, there's nothing else besides 1 and 31 that factors to get 31. So the only thing that comes out will be the I. And this is how I want you to write it. You can write like this, which most people will, or you can write it like this, which I need you to know because a lot of a lot of answers in SAT, ACT kind of stuff can vary it up. Those two are equivalent. Yes?
Why would you add the plus and minus?
Because the quadratic formula has the plus and minus. Okay, so that's a good question because the quadratic formula is factoring x squared, which is what you're looking for, the two answers. Yes?
Which equation do you want us to write on this?
To me, honestly, it's a great question. Honestly, I would want you to write this, but guess what? I prefer for you to build your math skills, for you to see it. Those are eyes, not these eyes. But anyway, to see it this way. Because math-wise, it helps you remember the things that you can do with fractions. Because look, it's not there, but what if What if 3 was a 6? What would I want you to do? Simplify this to 3 halves plus I root 31 over 4. Or, yeah, I want you to know how to do both. And then write it like this, but if it could simplify, break it up to something like this and then simplify it like that. Cool? Alright. You guys are doing very, very well. Great questions too. Oh, don't do it like this. Please don't do it like this. So you see where the I is at written in this textbook? I don't want it like that because if I wrote this, and some people will do this sometimes, I don't know, and sometimes people who write it don't know, whether this I is still underneath the square root. Do you understand? So, what we're used to seeing is this coming out as the I. Is this possible? Because isn't this the same as this? Oh, wait. Isn't this the same thing? You can, because this is still not only to that first one, but it's also to that second one. So it's saying the fourth root of a negative 1. I don't either. So that's what I'm saying is I don't want you to write it afterwards, write it before. Okay, so that you're not confused whether it's still underneath the square root radical sign. Cool? Alright. It does look confusing. Alright, let's see. That's similar to what we just did.